Good afternoon, students. Today we shall be discussing how can we carry out the chemical conversions, that is from one molecule to the other. We are taking the chapter Haloalkane and discussing question number 10.11 from the exercise. You may open the book. Now few steps you have to remember when you do the conversions, because during exam one or two conversions are invariably going to be asked in the exam. So the first conversion we are taking ethanol to but-1-ine. So whenever the compounds are given to you, your first job is to convert the name of the compound to its formula. So here it's given ethanol. So you know ethanol is an alcohol. Eth means 2 carbon. So the molecular formula is CH3CH2OH. Preferably don't write molecular formula. Preferably write condensed formula. So we are writing CH3CH2OH. So the next step is to write the formula of the product. The product is but-1-ine. Now what does but-1-ine tell us? But says the compound has 4 carbon. Ine says that there is a triple bond, and 1 says the triple bond is between carbon 1 and carbon 2. So that's how we write the structure. Now once you are done with the structure, now you compare the number of carbons in the starting material and in the product. So here you can see in the starting material you have 2 carbon and in the product you have 4. So normally whenever the number of carbon gets doubled, we have an intention to think that the reaction is Wood's reaction. But let me tell you, for Wood's reaction, the product formed is an alkane, and the alkane has to be symmetrical. But here you see the product is not an alkane, it is an alkene, and the product is not symmetrical as well. By symmetrical we mean we should be able to divide the molecule into 2 equal parts. But you can notice here the compounds cannot be divided into 2 equal parts. So definitely it is not an example of Wood's reaction. Then how do you go about it? Now since this is your first chapter and you know that it is from haloalkane, during exam you may not know this is from which chapter, okay? But since this is your from haloalkane chapter, you know, so some way or the other you need to get back to the haloalkane. Now don't look at the what is the compound, look at what class of compound it is. This is an alcohol, and if you want to convert alcohol to haloalkane, there are so many methods. If you remember, we have discussed. There was a Lucas reagent, there was phosphorus halide, there are phosphorus trihalide and pentahalide, and also SOCl2. Now, if you are given a choice, SOCl2 is named as thionyl chloride. If you are given a choice that which halogenating agent should you go for, practically SOCl2 is a better choice. Earlier also we have discussed, because during the course of reaction, the byproducts which are formed, they get evolved in the atmosphere. That means there is no extra step for separating the mixture. So that's why we have chosen SOCl2. But if you wish, you may write zinc chloride HCl, that is Lucas reagent. You may write PCl5, you may write PCl3, whatever. So the OH gets replaced by Cl. So we got this. The idea of converting alcohol to haloalkane is, we know that haloalkanes undergo tremendous nucleophilic substitution reaction, meaning the halogen can be replaced by suitable nucleophile in many ways. So which nucleophile do we need? We need the nucleophile, since my requirement is carbon triple bond carbon H. So the nucleophile must contain this group. And this we obtain from ethine. If you remember, in hydrocarbon chapter we have done this reaction HC triple bond CH, since the hydrogens are attached to sp hybridized carbon, and that's why this carbon is highly electronegative and the hydrogens attached here are highly acidic. So when you treat them with as sodium, which is an active metal, we get HC triple bond CNA. Okay. So that's how we get this product. Sodium acetylide is the name of the compound. So what happens? The halogen gets replaced. This from here NaCl will be lost. From here NaCl will be lost, and what you will get is the required product. Okay. So that's how we carry out this particular conversion. So this is done. Let's move to the next conversion. Ethane to bromoethane. Ethene. Ethane to bromoethene. So ethane, as the name suggests, it is an alkane having 2 carbon. So we have CH3, ethane. Then the product bromoethene. So ethene matlab there are 2 carbons with a double bond and there is a bromine attached to the carbon bearing double bond. So that is what is the starting material and the product. Now let us notice what are the changes. So first of all, we find that number of carbons in both the cases are remaining same. So it is neither a step up nor a step down reaction. Now what is the change? We can see the change is the alkane has been converted to an alkene together with a halogen. So we may have to think about how can we create an alkene from an alkane. As you know, during exam you will not get straightforward conversions. Most of the conversions are two-step conversion. So ethane reacts with chlorine in presence of sunlight. Remember, halogenating agent out here is, since alkanes do not undergo substitution reaction, so here we carry a free radical halogenation. So CH3 CH2 Cl, and once we get CH3 CH2 Cl, to create the alkene we need to carry out we have to heat it with alcoholic KOH. So when we treat it with alcoholic KOH, what happens? From here H and from here Cl is lost, and we can write here minus HCl, and we get CH2 double bond CH2. So we have successfully created the double bond. But now we need a halogen. So for this, we cannot simply introduce a halogen in the alkene just like that. So you have to first carry out bromination, since my required halogen is bromine, in presence of an inert solvent, that is carbon tetrachloride. So we get addition product. Both the carbons, they take up 1,1 bromine and again gets converted to a saturated hydrocarbon. Now from here we remove again alcohol, we again heat it with alcoholic KOH and HBr is lost, and that's how we get the product. You may look for some alternative methods if you find. Okay. So that's how we convert this ethane to bromoethene. Next is propane to 1-nitropropene. So what is the difference? Propine, that means prop means 3 carbon, ene means double bond. So we have written the structure propene, and then the product is 1-nitropropane. So in the 1 position we have nitro group and number of carbons remaining the same. So there is no change in the number of carbons, so it is neither a step up or a step down reaction. But the change is alkene got changed to alkane with a substituted product, that is nitro. So how can we carry about? Let's think backward. We know by nucleophilic substitution reaction we can create nitro, we can introduce nitro in the chain provided we have a halogen here. Now how can we get the halogen in 1 position? We can, if you do Markovnikov's addition, then bromine will come to position 2. And if you treat it with KNO2, then bromine will come to, sorry, not KNO2, it should be AgNO2. Please make a correction. If you treat it with AgNO2, then NO2 will come to carbon 2. But that is not my requirement. My requirement is NO2 should be in carbon 1. That means I need to add HBr according to anti-Markovnikov's rule, and for that I need a peroxide. So we add HBr in presence of peroxide, so H goes here and Br comes here, and that's how we get this product, 1-bromopropane. Now we treat it with, I just make the correction here, AgNO2, and here AgBr will be lost, and we get CH3, CH2, CH2NO2. What will happen if we take KNO2? If we take KNO2, we shall be getting CH3, CH2, CH2ONO. Okay, so there was a mistake here. Please make correction. Alright, the next conversion is really very commonly asked conversion and very important. It's toluene to benzyl alcohol. Now, one thing I have seen from my past years of experience, that most of the students, they fail to convert the name to the structure of the compound. So that is why it's very important that your nomenclature, concept of nomenclature is very clear. So toluene is a common name accepted by IUPAC. Actually, it is methyl benzene. So we write benzene with a methyl group, so that is toluene. And we can see benzyl alcohol means benzene ring with a CH2 and the OH is attached to CH2. That is what is benzyl alcohol. So this is my requirement. Now how can we go about this change? As you can see, the number of carbons are same here. There is no change in the number of carbon. So to introduce a halogen in the side chain, we have to do again free radical halogenation. So once we do free radical halogenation, what happens? The H out here gets replaced by Cl. And then it is simple. Then once you get Cl, you treat it with aqueous KOH. I remind you again, alcoholic KOH helps you in elimination. Aqueous KOH helps you in substitution. So the Cl gets replaced by OH and the byproduct will be KCl. Okay, this is a very important conversion. So that's how we do this conversion. Next is propene to propine. Propene, that is carbon, there are 3 carbons with a double bond. Propine is 3 carbon with a triple bond. So that means it is more or less clearly a elimination reaction. But you know, alkenes do not undergo elimination reaction so easily just like that. So we have to do something else. So what we do? We first add bromine in CCl4 as we have done before. So we get 1,2-dibromopropane. Now we need to remove, since I need a triple bond, we need 2 pi bonds here. Now how do we get 2 pi bonds? If I use alcoholic KOH, I will be able to remove only one HBr and we'll get a double bond. That means this product. But that is not my requirement. We need a stronger base which will be able to remove one HBr from here, another HBr from here, and then we get a triple bond here. And the name of this is sodamide, NaNH2, which is a much stronger base. So that's how you can carry out this conversion. Alright, next one is ethanol to ethyl fluoride. So ethanol, you know, alcohol, it's not written the structure in the question, it's written name ethanol, and ethyl fluoride. So here you can understand you need a fluorine. And if you remember, when we discussed the preparation of haloalkanes, there is only one method by which fluoro compounds can be prepared, and that is by Swartz reaction. And Swartz reaction come under halogen exchange. That means I must have a halogen here, then I treat it with a fluorinating agent, and then I get a fluoro compound. Sorry, here also I find a mistake. It is not minus AgF, it is minus AgCl. Please make these corrections. So we treat it with SOCl2 as before, as we did in question number 1, and we get chloroethane. And once I get chloroethane, we can carry out treatment with any of the fluorinating agents, silver fluoride, mercurous fluoride, antimony fluoride, whatever, and we get CH3CH2F. This was comparatively easier. Now instead of ethyl fluoride, if they ask you ethyl iodide, then what you can do? Instead of AgF, you can use NaI, Finkelstein reaction, and you get iodoalkane. Remember, conversions you cannot mug up. There are thousands and thousands of conversions. How much will you mug up? You need to understand how should we go about it. Okay. So you will not become expert in one day. Slowly you will develop the skill. But for that you need to practice a lot. Next is bromomethane to propanone. So here you see bromomethane. Methane means 1 carbon. And propanone, prop, means there are 3 carbons. So there is clearly increase in number of carbon. Bromomethane is a haloalkane having 1 carbon. Propanone is a ketone having 3 carbon. So we know what is our starting material and what is our product. Now we have to think about how can we carry out this conversion. We will do the conversion making use of the first method. If you remember, in the first method, what did we do? In the first reaction, we have used this one, remember? Sodium acetylide, which helps you to increase 2 carbon. So here also our requirement is to increase by 2 carbon because we already have 1 carbon in bromomethane, and in propanone we need 2 more carbons. So we can make use of the same reaction. So what we do, we treat it with sodium acetylide again, and we get a triple bond here, propine. And this reaction you have done again in class 11 under the properties of alkynes. When you do hydrolysis in presence of mercuric ion and H plus ion, as you can see here, it's written class 11 syllabus. So you get an enol. Okay, now what is enol? Enol means the carbon bearing double bond and OH. In because of double bond alkene and ol because of OH. Now the addition of water takes place according to Markovnikov's rule. So negative part goes to the carbon having lesser number of hydrogen. So out of these 2 carbon, I don't have any hydrogen here. Here we have 1 hydrogen. So wherever it is less, here it is less. So the enol which we get, this is called propinol, is not very stable. I request you to refer to your class 11 notebook notes again. And it immediately rearranges itself by a process called tautomerism, and it gets converted to propanone. Alright. So that's how we carry out this particular conversion. Now next move to number 8. But1in to but1in. Very interesting conversion. But, in. Only difference is 1 in and 2 in. So they are position isomers. So it has been told that whenever there is position isomer, one position isomer changes to another position isomer, the common steps are either addition followed by elimination, okay, or reverse. Elimination followed by addition. Now here what is likely to happen? Since your starting material is alkene, it is more likely to undergo addition reaction. So we add HBr without any peroxide so that we get Markovnikov's product. Here Br gets added up, here H gets added up. Now since my requirement of alkene is here, now you can see this particular carbon has 2 alpha positions, and here we have CH3 and here we have CH2. Now here you have to apply Sage-Zeff rule. And don't tell me now you don't know what is Sage-Zeff rule. If you don't remember, you can always go back to your class 11 notes. We have discussed it before. Sage-Zeff rule says that during an elimination reaction, if there are 2 possible products, the more alkylated alkene will be the major product. So here, instead of losing H from here, which will give you back this, which is not my requirement, the H will be lost from here because this will be a more alkylated alkene. And how can we carry out this conversion? By heating with alcoholic KOH. So this, remember, whenever there is isomerization reaction, that also position isomerization reaction, always the test steps will be either addition followed by elimination or elimination followed by addition. Okay, the next one is very simple, one-step conversion. 1-chlorobutane to N-octane. So here what is our starting material? It's a butane, that means 4 carbon. 1-chloro, that means there is a chlorine in position 1. N-butane, octane, sorry. Octane means there are 8 carbons. N means it is straight chain. So you can see a haloalkane have been converted to an alkane, and that also by doubling the number of carbon, and it is symmetrical. So it is just one-step conversion. You know, it is very simple. It's Wood's reaction. So we simply treat it with sodium in dry ether and we get the product. The next is benzene to biphenyl. So this is our benzene, and biphenyl means 2 benzene rings joined together by a single bond. Remember, biphenyl is not same as naphthalene. It is different. So, you know that biphenyl we get by Fittig reaction. But for that we need chlorobenzene or any halobenzene. So, how can you introduce a chlorine in the benzene ring? Definitely not by free radical halogenation. We introduce a chlorine in the benzene ring by Friedel-Crafts halogenation. That means treating it with a halogen in presence of a Lewis acid catalyst. You may take anhydrous AlCl3. I have taken here iron. So when we carry out this halogenation reaction, halogen gets introduced in the benzene ring directly, and then we treat it with sodium and dry ether. For aromatic compounds, the Wood's reaction itself is termed as Fittig reaction. If you take aliphatic compounds, it is Wood's reaction. If you take aromatic compounds, it is Fittig reaction. So that's how you get the products. So we have finished discussing this question number. There were 10 questions. Now there are some more conversions, around 20 conversions in question number 19, 10.19. But you will find question number 2, 4, 8, they are repetition of whatever we have done in 10.11. And you please cancel question number 10.19 part 14 and part 20. This cannot be done by using the concept whatever you have learned from this chapter. Those can be done when you go ahead with the syllabus. So with this we stop the class today, and I'll ask you to do the conversion of 10.19. I'll give you the hints, but you have to do on your own.